Let's have a look at the last question in this paper, and it's a projectile question. So this will come up every year. Let's have a look. So a boy throws a ball at target. At the instant when the ball leaves the boy's hand at the point A, the ball is 2 meters above horizontal ground and is moving with speed u at an angle alpha above the horizontal. So first we can resolve this velocity. So one horizontal, one vertical. So horizontal will be u cos alpha, vertical will be u sine alpha. And then in the subsequent motion, the highest point reached by the ball is 3 meters above the ground, which is labeled here. And the target is modeled as being the point T as shown in figure 4. The ball is modeled as a particle moving freely under gravity. And then using the model, show that u squared equal to 2g sine alpha. So let's check what we know so far. So if we want to use the horizontal direction, we only know u is equal to u cos alpha, the initial velocity, and we don't know the horizontal displacement, and we don't know the time. So we don't have enough information because there are two unknowns, so we can't really use the horizontal direction. So if we use the vertical direction, then what we know is we know the initial velocity. So if we take point A as the starting point, then the initial velocity is equal to u sine alpha. And we can't take the end point because we don't know where point T is at this moment. Yeah, it tells us later, but not now. So we can't use point T as the end point. But they did tell us the highest point reached is 3 meters above the horizontal ground. So we can use this one as our end point. So start point, end point. So then the velocity at the highest position should be equal to 0. So the reason is highest point because there will be no velocity to make it move up anymore. So the highest point, the velocity has to be equal to 0. And then A is equal to negative g. And S is equal to, so this is 2 meters above the horizontal ground. This is 3 meters above the horizontal ground. So that means from the initial position to the end point, so the displacement should be this 1 meter. So let's label it here. So S is equal to 1 meter. Okay. So V, U, A, S. So it has to be V squared equal to U squared plus 2AS. So V equal to 0. U is U sine alpha, and we square that. And then plus 2 times A, which is negative G, times by S is equal to 1. Then we have 0 equal to U squared sine square alpha minus 2G. So that means u squared sine square alpha is equal to 2g. Therefore, we have u squared equal to 2g over sine square alpha. Then that'll be the answer for part A. Okay, part B. So point T is at the horizontal distance 20 meters from A. So if it's 20 meters from A, we know, yeah, the horizontal distance, this is 20 meters. And then it's at a height of 0.75 meters above the ground. So that means this will be 0.75 meters. And then we know originally A is 2 meters above the ground. So that means the vertical distance change will be 1.25 meters. Okay. And the ball reaches T without hitting the ground. Find the size of the angle alpha. Okay. Now we know the horizontal distance, so we can use the horizontal position. So for the horizontal position, we know U is equal to U cos alpha. And then the distance would be 20 meters. So we still don't know the time T, but at least we only have one unknown, so we can form the equation. So distance is equal to velocity times time, because in the horizontal direction, velocity never change. So we don't need to use SUVAT. We just have to use velocity times time, give us distance. Then we have one equation. And if we look at the vertical direction, so again, we know the initial velocity will be u sine alpha. And this time, we will use point A as our start point. And then point T will be our end point. So we don't know the velocity at point T, so we don't know what V is. So we don't know. But we know S is equal to negative 1.25 meters. And we also know acceleration is equal to negative g. So we know S, we know A, we know U, we know V, and then we don't know what T is. So we can set up our second equation. So S is equal to UT plus half AT squared. So the reason we use S equal to UT plus half AT squared and not V squared equal to U squared plus 2AS is because, so for this one, we don't know what V is. And also for U, we don't know what U or alpha is. Yeah. But if we use S equal to UT plus half AT squared, so we only have T we don't know, but we can use the previous equation to rearrange this to get T equal to 20 over U cos alpha. So once we substitute in, we only don't know U and alpha. But for this one, we not only don't know U and alpha, we also don't know V. That's why we don't use this equation to set up. Yeah. So we use S equal to UT plus half AT squared because this is less unknowns. All right. Let's put the values in. So negative 1.25 is S, and then U is U sine alpha. And then we already rearrange it. So we know T is equal to 20 divided by U cos alpha. So we can put that in 20 over U cos alpha. And then plus half, and then A is negative G, and then times by T squared, which is 20 over U cos alpha squared. Okay. And then now simplify this, we have negative 1.25 is equal to, so U over U cancels out, sine alpha over cos alpha, that's tan alpha. So we can write as 20 tan alpha. And then minus G over 2. And then 20 square is 400. And then over U square and then cos square alpha. So now we have negative 1.25 is equal to 20 tan alpha minus 400G over, so we already know U square is 2G over sine square alpha. So then we can change that into, so 2 times by U square, which is 2G over sine square alpha. And then times by cos square alpha. So then that will give us negative 1.25 is equal to 20 tan alpha minus 400G over, so 2 times 2G, that's 4G. Cot square alpha over sine square alpha, that would be just cot square alpha. And then G over G cancels out. 400 divided by 4, that's 100. And then that will be negative 1.25 equal to 20 tan alpha, and then minus 100. So 1 over cot square alpha is equal to tan square alpha. So we can do 100 times by tan square alpha. So put into the correct order, 100 tan square alpha minus 20 tan alpha, and then minus 1.25 equal to 0. So now we just have to put this into the quadratic equation. So A is 100, B B is negative 20 and C is negative 1.25. That will give us tan alpha equal to 1/4, or tan alpha is equal to negative 1/20. And then clearly this one is not valid because alpha cannot be more than 90. So this will give us a negative value for angle. And if you plus 180, that would be an obtuse angle. So it's not valid. Or you can just literally work it out. So tan alpha is negative 1/20. So tan inverse of negative 1/20 will give us negative 2.86. And then tan, you just have to plus 180 each time. So that would be 177.137. So both of the answer is not valid. So we cannot use this one. Yeah. And then tan alpha equal to 1/4. We can just do tan inverse of 1/4, which is 14.03. So we can just round it 14 degrees. Then that would be the answer for part B. And then for part C, it says state one limitation of the model could affect your answer to part B. You can either see like the dimensions of the particle, dimensions of the ball, because it's modeled as a particle. Yeah. Or you can say the spin of the ball. That's normally what I write in this type of question. Yeah. But there'll be more possible answers. You can always check the mark scheme. And then for part D, find the time taken for the ball to travel from A to T. So time taken, so we already have this T equal to 20 over U cos alpha. So we can just substitute in now. So T is equal to 20 over U times by cos alpha, and alpha is 14. So that'll be cos 14 degree. And then we know U is equal to U square is equal to 2g over sine square alpha. So that means U is just equal to square root 2g over sine square alpha. So we can just substitute in. So 20 divided by square root of 2g over sine square alpha. And then the angle is 14 degree. So it'll be sine square of 14 degree. And then we times by cos 14 degree. So put that in the calculator, it will give us the answer. So 20 over square root of 2 times 9.8 over sine 14 degree square, and then times by cos 14 degree. So that should be 1.126. We're going to round it 1.13 seconds. And that will be the final answer.
Thank you for watching the video. If you have any questions, you can leave some comment. And then if you find the video helpful, please like it and subscribe it. May the A star be with you.